Good day, everyone. My name is Modestus. I'll be making presentation on transshipment model for multi-echelon systems and manufacturing operations. The background. The idea behind this research is trying to compare the traditional heuristic with global heuristic, because a good number of manufacturing companies or factories respond to changes of product demand from customers, thereby creating intricate chains that could not be responded to adequately. So this study addresses a case of distribution faced by a manufacturing company where product is to be supplied from source to multiple destinations. So the interest is to view the best possible ways of making allocation decision at optimal cost. So the problem statement here, some of the challenges facing manufacturing industries in today's business is how to consistently meet with customers' requirements and demand at various destinations at lowest possible costs. So managing inventory in multi-echelon system is much more difficult than managing such in a single system. So unfortunately, managers rely on rule of thumb and heuristic methods in making allocation decision. The rule of thumb has never guaranteed optimal solution. So it's very important to now look at a much more robust algorithm for solving this kind of problem. So the objective now. The main objective of this study is to develop a mathematical model to optimize the total cost of product distribution using two companies as case studies. And the specific objectives include to develop a robust optimization model for product distribution, develop solution procedure for the model using meta-heuristic techniques, and address the shortfall of the heuristic techniques, and possibly develop an outbound hybrid artificial intelligence system, which is the adaptive neural inference system. Then collect data from manufacturing companies and use it to validate the model to develop a much more robust solution. In scope of the study is narrowed to the use of meta-heuristic techniques and hybrid algorithm in effectively allocating products and optimizing costs in a manufacturing company. And the company of case study is the Nigerian bottling company. And the justification of the study is necessary because a high operating costs are associated with distribution of products when facilities are not properly planned. And the traditional heuristic techniques used in time past have never offered a good solution. Most of them are based on rule of thumb, and there is therefore need to look out for a much more robust algorithm. And in this study, we're looking at the artificial neural network and a hybrid algorithm that's a breed of neural network and fuzzy inference system. So with the hope of optimizing costs in the manufacturing systems. Looking at a review of literature, a good number of researchers have done, developed solutions based on heuristic techniques. Least cost method has been used for problem solving. Linear programming model has been used effectively. Vogel approximation has also been used, and modified distribution method for solving heuristic problems. It's therefore necessary to look beyond that here. Some researchers have also used the neural network for this problem solving system, but the hybrid algorithm is the novelty behind this research, trying to demonstrate the power of adaptive neural inference system in making allocation decision. Then the methodology. This chapter focused on problem description, the model development, model parameterization. Then a transshipment model for product delivery was developed, looking at intermediary points, a system where there is a source, there's an intermediate point where products can flow to for onward distribution to the final destinations. So this is the architecture of the model for the two-echelon system, a direct system where products can flow from plants to different destinations. And here is a system where products can flow from source through intermediate point to the final destinations. Now, the analytical tool, we'll be looking at the heuristic techniques based on least cost method, looking at linear programming methods, then the Other heuristic techniques will be compared with the artificial neural network, which is a meta-heuristic technique, a fuzzy inference system, and also a hybrid model that breeds both the neural network and the fuzzy inference system. This is the adaptive neural fuzzy inference system. Now look at the modified neuron structure. Yeah, this system shows how the ANN is patterned in such a way that information can flow from external source through some nodes, and it goes straight to the summing junction. That's like a controller. At the summing junction, there's a kind of synaptic weight that decides the information that flows into the system and the ones that should be repelled. So if the information going into the system is okay, then it can be accepted at the synaptic weight. At the summing junction, the controller system accepts good information and rejects the bad ones. And it goes through the activation function to the output signal. So looking at the behavior of this neuron structure, it became very important to synchronize this and use it to solve real-life problems by demonstrating what this can do in real life. And we're saying the fixed inputs, which is information flow from external source X1, X2, X3, X4, can represent product flow at different manufacturing centers. And the nodes WK0, WK1, WK2 on the neuron can represent the transshipment operations, that's intermediate points where products can flow to for onward distribution. So at the summing junction, there's a kind of controller system that will decide where the information flows to, whether it's going to come from the synaptic weight straight into the summing junction or be repelled. So here we're going to demonstrate that using the current MATLAB, where we're going to test the data obtained and try to solve the problem using the adaptive neural fuzzy inference system. The equation of the neuron is presented here. And the next slide, we go straight to the use of adaptive neural fuzzy inference system. The hybrid algorithm that has been used to solve problems in diverse fields is far more superior to the neural network and fuzzy logic control systems. So ANFIS is considered a powerful tool for modeling complex systems in any domain. So it's easier to solve problems using ANFIS than using it to solve problems using ANN or fuzzy logic. The reason is that ANFIS gives a faster response to solutions and also gives a much more accurate results. This is the architecture of the adaptive neural fuzzy inference system here. And the next slide, this we present here the first data set based on the products obtained from a paint manufacturing company with two sources and multiple destinations. So the first case scenario is a paint manufacturing company, and the company has two different sources, and products can either flow from source 1 or source 2. But the problem with this is trying to know exactly when product is made available, when demand is being made, how do we supply products? Are we to supply the product from source 1 or source 2? And that's exactly what we're going to address using this interesting model. This is the architecture of the system, product flow from source to destinations. There is source 1 and source 2, and there are many destinations. Destination runs from depot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And products can either flow from either source 1 or source 2. But the problem is, where do we make allocation from where products are available at the two systems so as to optimize costs? Now look at the case scenario based on products obtained from data sets obtained from the manufacturing system. The first system has a product of about 40,900, and the second has about 35,000 products. And there are so many destinations where products can flow. And in order to solve the problem, we decided to test the validity of this model using the adaptive neural fuzzy inference system. So on the ANFIS model, we have here the equation of the model, and bringing in the data sets into the model, you have from the first equation where VK equals to UK plus BK, the linear combiner with bias to support the input signal is presented based on products, the source to source, so multiple destination systems. So this was done, the first trial was done using the neural network, and it is revealed here that training for the training, we obtained R value of 0.996 and the validation model of about 2.93, and the test result is about 0.90388, and the overall is about 0.47, which shows a fair prediction of the model. And the summary ANN presented shows a good results. Yeah, but it became necessary to test also other models apart from ANN. Cost has been reduced significantly using the ANN model, but it is important to also demonstrate the strength of the adaptive neural fuzzy inference system. Here we present the fuzzy inference system model, and let me go straight to the next slides for the adaptive neural fuzzy inference system. The model of ANFIS, which is a hybrid algorithm, combines the neural network and the fuzzy inference system. So trying out this is the architecture of the adaptive neural fuzzy inference system, showing the synchronization of the ANN and the fuzzy inference system. So now testing the model using the ANFIS adaptive neural fuzzy on MATLAB 2020. There's a rule viewer for supply signal from source to destinations. So this has been able to give us, after loading the data sets, and we got a rule viewer on ANFIS model that shows the input variables. So what we do is, by trying to perform sensitivity analysis, we can check out what the output solution will look like based on the architecture we're looking at here for the different input variables to the output variables. So any change we make using cost as an input variable and demand as an input variable, we'll be able to confirm what the output solution and result will look like. So having done this, the summary shows that the model developed is highly effective, as the solution obtained from ANFIS is superior to that of ANN and also the classical model. So for the second case study, we tried a bottling company, and the bottling company has a source and multiple destinations, and the problem has always been the issues with costs, optimizing costs. So in order to optimize costs, it became necessary to go closer to the system and look at how they make allocation. I'll quickly show you the architecture of the system now. This is the source, the bottling plant, and with multiple destinations. So it's possible to supply product from source to any of the destinations. So in order to optimize costs, it becomes necessary to now develop what's called the transshipment model. So instead of product flowing from source to all the destinations, we can decide to create transshipment points by using heuristic technique. Having performed the heuristic search, we chose 3 transshipment points out of the 10 different destinations, so that products can either move from the plant to these 3 destination points for onward flow to the final destinations. Now look, we can also demonstrate the strength of ANN using ANN to solve the problem of the bottling plant model. So we developed the bottling plant model for this problem. This is the mathematical equation here. Then this is the linguistic techniques under fuzzy inference system. Then we have here the surface plots generated. And finally, we got our solution for product flow from source to first transshipment points, and product flow to the second and third transshipment points here. And finally, we obtained what the solution response will look like. And at the end of the day, it showed clearly that from here, total cost of distribution from source to transshipment points give us total value of this as presented, and total cost of transshipment is the total distribution cost at the end of the day using the adaptive neural fuzzy inference system is about 4 million as compared to about 6 million spent by the company. So meaning that if the company decides to use this interesting algorithm, it will go a long way to save cost of distribution. Yeah, so conclusion, we are having discussed this intensively, looking at the solution obtained from ANN and ANFIS. It is very clear that the company spends so much using the normal rule of thumb. company spent about more than 8 million distributing products from source to different destinations. But we tried to use the transshipment model and develop an ANN. We further developed ANN model and obtained a solution of about 6 million, far more than 6 million naira. Yeah, and using the ANFIS model, we're able to obtain about reduce cost to about 651,300 for ANFIS, 692,100 for ANN, and 833,050 for the rule of thumb used by the company. So at the end of the day, it is very clear that the company would have saved a whole lot of money using the adaptive neurophase inference system. So it is suggested that companies can shift away from the traditional approach to using a kind of a higher algorithm based on adaptive neurophase inference system. So it shows that the global hybrid algorithm is far superior to the single algorithm. So researchers can start looking at how to possibly use the adaptive neurophase inference system for problem solving, especially when it has to do with supplier selection and also cost optimization. Contribution to knowledge. In time past, researchers have been using the linear programming approach for solving transportation problem, especially the northwest corner method, greedy heuristic, Vogel approximation method, and modified distribution method to optimize cost of distribution in systems. It has become necessary to shift away from these traditional techniques to a much more robust technique based on neural network, fuzz inference system, or the adaptive neurophase inference system based on a hybrid algorithm. So, but it is recommended to use the adaptive neurophase inference system. It's far more superior to using single algorithm based on ANN and fuzz inference system. Recommendation. It is recommended that other meta-heuristic techniques can be further researched on to test the strength and solution power of these models. At the end of the day, comparative analysis can be made, and this can be done in upcoming research. Thank you very much for listening. Thank you. Then we'll have some research work based on what we've done in time past. You may wish to look at some of them. OQMO and Tatibu 2021, then OQMO et al. 2020, where we try to solve problems based on application of ANN for solving problem distribution models in manufacturing systems. Then Oku, Emo, and Olufemi also did a research on comparative analysis of ANN and the adaptive neurophase inference system or in non-deterministic system inputs here. Then we have also done research on supplier selection using the adaptive neurophase inference system. Thank you very much for listening.